All right, so this is very confusing, right? The difference of the two proportions. It means that you are checking whether the two groups have different proportion of a certain category. So we are using the categorical variable as a dependent variable and dichotomous variable as independent variable, because for the t-test we can just use two groups as an independent variable. So that's why we are covering this in case we have the categorical dependent variable. So in case you have the categorical variable for your final paper project, then you can use this analysis. So here we can see if we are checking that the acceptance level of the suicide. So suicide is acceptable if someone is tired of living. In that case, the male answered yes, around 24.5%, compared with the 19.4% of the female. So we can see the proportion of answering yes indicates the acceptance level of the suicide for some people who are tired with the living. 24.5% and 19.4%. So we can see 5.1% difference in here. So categorically, the percent means out of 100. So usually you can multiply 100 from the proportion. Then you can create the percent. For example, so 24.5% is calculated as 165 divided by the 673. So that is the proportion of answering yes of the male of the total sample size of the male. So 165 divided by number of cases of the male sample multiply 100. So that will be 24.5%. So same with the female side. So in this case, so you may know in the mathematics, the exchange theory, if you multiply the same number or if you divide the same number on both the left hand and the right hand side, it will generate the same calculation. So there was the 100 calculation. So there is the 100 multiplication. You can divide 100 in both sides. I mean the left hand side and the right hand side. So that will be just 0.0245. So and then 0.195. So simply you can just calculate you can just divide 100 from those percentages so that you can create a proportion. So 24.5%, you can divide it as 100, then it will be 0.245. And then if you divide the 19.4%, that will be 0.195. So simply, if we want to transform or transfer the percent format to the proportion format, you can just divide the percent out of 100. So that will be the proportion format. So the steps 1, 2, 2, 4, 3, 4, this is very similar with the independent sample. And then the setting the null is very simple again. If there is no difference, that will be the null hypothesis that there is no difference in the acceptance level or proportion of the accepting the suicide by gender. And then the alternative hypothesis means that there is difference between the proportions by the gender. So if there is no proportion differences, it means that by the gender, or we don't find any differences. So gender is not a significant or statistically significant independent variable. So that's what we mean here. So step 2, the setting the critical region. So critical region, the critical area. So very similar with the independent sample. There are two groups, right? Male and female. So these are very separate groups. So number of cases of the male -1, number of cases of the female -1. That will be 1,520. So that's very easy, right? So let me skip this part because we already covered a lot. So you can just compare, you can just check the table and then you can check the critical value at the alpha level 0.05, and then you can change the intersection between them. So you can review my lecture slide of the previous weeks so that you can follow this format. Alright, so we found that 1.965 in both sides, in positive and negative, these are the critical value. It means that if your t statistic is inside, inside this blue color area, it means that you can reject the null hypothesis. Again, if your t statistic is between those critical values, so in this unshaded area, it means that you cannot, or you fail to reject the null hypothesis. So because you failed to reject your null hypothesis, you are saying that there is no difference in those two proportions. Okay, so calculation process. This is very difficult and very complex, but if you just know the order of the calculation, and if you make some successful calculation of the P star, the calculation will be easy. So the numerator means the difference between the proportion 1 and proportion 2. So proportion of the supporting or accepting the suicide if someone is tired of living of the male side minus of the female side. So that will be the difference between those two proportions. It's very simple. And then the standard error is a little bit very difficult. So you can go to the next slide. P1, that is, as I said in the previous slides, 0.245, because you can just divide 100 to the 24.5. So you can calculate it. So usually if you move the dot, the point to the left side, you can change it as a maybe after dividing 100, if you move the point to the two stages, that will be on your calculation result. So it was 24.5, but the point is moved to the left to the 2 points. So that will be 0.245. It's saying 19.4, the point is moved to the left 2 steps. So 0.194. Or if you are not familiar with this kind of process, you can just simply divide on those numbers as 100. So that will be your proportion 1 and proportion 2. Number of cases, that's also simple. Number of cases of the male, you can find it here in the total. In the male, the total number of male is 673. Total number of female is 849. So that will be here. So the P star, which is the pooled, so that is that's what we call the pooled variance. Because if we go to further details, so as I told you in the lecture, because there are two different samples, and we assume that the male and the female would have a different variance because they are separate people and the separate group. Because that's we are assuming that those people are different from each other. Male and female, they are different. So that this is the adjustment of the two different variants in the same one. So after that, you can adjust your variance and then calculate the standard error by using this calculation. So it's a little bit further of the analysis, but this is the only way to adjust those two groups' variances. And then you can use the Excel in this type of the calculation. So N1 673. So you can simply type 673 in the N1 and 849 in N2, 0.245 in the P1, 0.194 in the P2. So P star is what we need to calculate first. So the numerator, so let's make the numerator here. So wherever you are more convenient. The numerator is N1 multiplied P1 plus N2 multiplied P2. So that will be, the numerator will be, and the equal, you need to start it from equal, 673 as N1 multiplied by P1. So that will be here. And then plus N2, so I'm here, so focus here. Okay, N2 multiplied by P2. All right, so N1 multiplied P1 plus N2 multiplied by P2 here, right? Okay, this is the numerator. And let's calculate the denominator here. So N1 plus N2, that will be N1 plus N2. If we prepare the hand calculation or manual calculation, you can use calculator. But if you are not interested in that, maybe you can try to calculate using Excel. Because for your assignment or your exam or any kind of the questions that you will need, you will have the time limitation. So that's why I'm using this one. But if you're familiar with the hand calculation or manual calculation or calculator, using the calculator, you're fine to use that. So I'm just trying to find a way that the shortcut. But anyway, if you're confused with that, maybe you are fine with using calculator. So the denominator and the numerator and the denominator. So divided by this number of cases. So okay, divided by. Okay, so in here I rounded off the 0.22. So if you wanna decrease the number of decimals, you can go to in the number section here, and this is a decrease decimal. Okay, so here, okay, decrease decimals, right? Okay, then you can round it off in 2 decimal places or 100 decimal places. So you can see what I created here, right? And the SCM of the P, that's a little bit tricky part. Then, so that will be squared root. Before then, we need to make the square root part. Before the square root part, because we can make a square root again. So that will be, so P is here, right? And then, all right. So this is the calculation process in the order. The multiplication is calculated first or prior to other plus or subtraction. We need to make the parenthesis or the bracket. So as I make this calculation or in this equation, you can make the bracket or the parenthesis as I did in here. So I'm calculating inside of the square root first. So then maybe 1 minus P star, all right, and then multiply n plus 2, n1 and n plus 2. That will be, I already calculated here, but not, I don't wanna confuse you. So that will be n plus 1 here, right? No, and n1 plus n2. All right. So divided by. So in this case, for the better calculation, so you'd rather make the parentheses again because they are inside same one. So n1 plus n2, n1 multiplied by n2, they are separate. So that's why I'm adding the parentheses. So very basics of the mathematics again. So that will be that will be n1 multiply n2. All right. So this part here, B9, that is the P star, and 1 minus P star here. So you can see compatible right here. And B5 and B6, that is the N1 plus N2 in the calculation. And divide N1 multiply N6, N2. Right. So 0.0000452. So as I said, this is the before doing the square root. So it will be equal as QRT, which is a square root. And then So again, if you want to decrease the decimal places, you can go here. All right, so here. So we calculate the standard error or sampling error of these proportion differences, and P1 minus P2 is very simple, right? Because that is P1 minus P2 here. All right, so it will be the numerator is P1 minus P2, all right? P1 minus P2, and then divided by the sampling error of the proportion differences. So decimal places differences 2.4, whatever. So we have the 2.4 as our t statistic. So our critical value we already calculated here, or found here, 1.965. So in this graph, we can see that our t value is inside of the shaded area. It means that we can reject the null. So there is a statistically significant difference between the proportion of accepting the suicide by male and the proportion of accepting suicide by the female. So we can see that we can also conclude that males are more likely to accept the suicide if someone is very tired of living. So more likelihood of the acceptance of the suicide by male. All right, so that's it, and I covered it in my lecture, and in my lecture slide you have it, and you have the video. So I hope you are ready to solve the question number 4 in our analysis or in our lab assignment 4. And again, because I skipped the effect size in the independent sample means and this part, so you can ignore the questionnaire about the calculating the effect size B. All right, let me know if you have a question by email or my office hour or my class hour, whatever time. Okay, good luck.